Hello everyone. In the previous video we have seen how to solve the model problems based on the inverting amplifier op-amp circuit. Now in today's video we are going to see how to solve the problems based on non-inverting amplifier circuit. In brief, let us discuss what is a non-inverting amplifier. As we know that this non-inverting amplifier circuit is nothing but here this input signal is given to the non-inverting terminal of op-amp and therefore we will find the output voltage V0. Here we are assuming that the op-amp is an ideal op-amp. Since the op-amp is working in ideal case, we can say that the non-inverting terminal potential is always equal to the inverting terminal potential. So I can say that the node voltage at B is always equal to the node voltage at A. Okay, so for this type of circuit we have derived the output voltage expression V0 as 1 plus Rf by R1 into Vi. So this is the major formula we have to remember while solving the non-inverting amplifier problems using op-amp. Now let us see the first problem, that is they have given that the output voltage of the non-inverting amplifier we have to find with given that the input voltage Vi as 1 volt. This circuit will similarly looks like the non-inverting amplifier circuit. Here they have given that the input voltage Vi as 1 volt and the feedback resistance Rf is 9 kilo ohms and the resistor R1 is 1 kilo ohm. Okay, so for this type of circuits we know the value of output voltage V0 as 1 plus Rf by R1 into Vi. Given that Rf is 9K and R1 is 1K and Vi as 1 volt, which is equal to K cancel. So 1 plus 9, 10 volts. So for this amplifier the output voltage V0 is 10 volts for the given input voltage Vi as 1 volt. Now let us see the next model, that is frequently asked. So here they are asking to find out the output voltage of the non-inverting amplifier circuit given that the gain as 10 and input as 5 volts. Okay, so here they have given that gain value as 10 volts and the input as 5 volts and they have asked to find the output voltage V0. Simply from the basic definition of gain, that is the gain is the output voltage of the circuit to the ratio of input voltage, or I can say that the ratio of output voltage to the input voltage. So I can write the gain of a non-inverting amplifier, it is a closed loop gain. So ACL is equal to V0 by Vi, which implies V0 is equal to Vi into ACL. Given that Vi has 5 volts and ACL has 10, so finally the value of V0 is 5 into 10, which is equal to 50 volts. So simply, if you are not remembering the circuit formula also, we can easily solve by remembering the basic definition of gain of any amplifier circuit. This is the second model they are frequently asked. Now let us see what is the third model that is frequently asked in the previous exam. Simply they have given one non-inverting amplifier circuit. Here this input voltage Vi they have mentioned as 1 volt. For this type of circuit, what we have to find? We have to find the output voltage V0 and the current I and the load current IL and the output current I0. So if you see the circuit, this I0 is the current getting from the output of an op-amp and IL is the current flowing through the resistor RL and I is the current flowing through the resistors 9 kilo ohm and 1 kilo ohm. Okay, similarly for this case we are assuming that the op-amp as in ideal case. Since the op-amp is ideal case, the positive potential is always equal to the negative terminal potential. So here the positive is connected to the input signal Vi. So that is given it as a value 1 volt. So at this point I can say that it is indirectly connected to the input signal Vi. If you observe this, it simply looks like the ideal non-inverting amplifier circuit. So for the ideal non-inverting amplifier circuit, we can find the output voltage V0 from the basic formula as 1 plus Rf by R1 into Vi. They have given Rf as 9 kilo ohm and R1 as 1 kilo ohm and Vi as 1 volt. So simply substitute these values, then we get 1 plus 9k by 1k into Vi as 1 volt. So k gets cancelled, 1 plus 9 is 10, so 10 into 1 is 10 volts. So finally the value of V0 is 10 volt. Now next what they have asked, they have asked to find the value of current I. From this circuit we can say that the current flowing through the feedback resistor 9 kilo ohm is always same to the current flowing through the resistor 1 kilo ohm, since the current entering at the op-amp terminal is 0. Okay, so from this current equation we can write the I value as Vi minus 0 by 1 kilo ohm. So Vi value is 1 volt, 1 by 1k, I can write I value as 1 milliampere. Okay, so we have find the value of voltage V0 and the current I. Now we have to find the value of load current IL. Since this load current is nothing but the current flowing through the resistor RL, we have already obtained the value of V0. So finally I can write IL as V0 minus 0 by RL. So V0 is 10 and RL is 1K. So IL as 10 milliamperes. Okay. Next we have to find out the value of I0. So here this I0 is entering at this point. Okay. Whereas the currents I and IL are leaving at that point. So simply apply KCL at node V0. That is, the sum of entering currents is always equal to the sum of leaving currents. So entering current is I0 and leaving currents are I and IL. So it is I plus IL. Already we have find the value of IL as 10 milliamperes and I as 1 milliampere. Simply substitute it, we will get 1 milliamperes plus 10 milliamperes. So finally the value of I0 is 11 milliamperes. In this way we have to find the output voltage and the currents of the given non-inverting amplifier circuit. Now let us see the next model they are asking. So here simply they have given one circuit. So for this type of circuit we have to find the output voltage V0. Okay, so here this input signal is applied to the non-inverting terminal using the resistors. Okay, up to here I can say that it acts as a non-inverting amplifier circuit with the input voltage VB. So first I will write from the definition of ideal non-inverting amplifier circuit, that is V0 as 1 plus Rf by R1 into input voltage. Now what is the input voltage that is applied at non-inverting terminal? So the voltage that is applied at non-inverting terminal is the voltage present at this node B. So I can write it as a VB. Okay, now simply substitute the value of Rf and R1. So it is 1 plus 9k by 1k into VB. So finally the value of V0 is 10 VB. Now we have to find this value of VB and therefore we have to substitute in this equation. Now how we will find the value of VB? Simply we will apply this potential division rule at this node VB. So by applying voltage division rule or potential division rule at node B, we get VB as total input voltage Vi into the corresponding branch impedance 9K by total impedance, that is 1K plus 9K. So Vi as 1 volt. So 1 into 9K by total voltage is 10K. KK cancel. So finally the value of VB we are obtaining as 0.9 volts. Now simply substitute this obtained value of VB in this V0 expression. So finally we will get the V0 as 10 into 0.9, which is equal to 9 volt. So in this way we have to derive the output voltage V0 by remembering the ideal non-inverting amplifier output voltage formula. Or else we can solve this value of V0 with the theoretical definition, that is by applying a nodal analysis at VB and also by applying nodal equation at node A. After that we have to assume that the op amp is an ideal case and equate this VA equation and VB equation. Thereafter we will get the value of V0. So this is the procedure how to find the value of V0 for this type of circuits. So these four are the major problems that are asked in the previous year question. Thank you so much.